So our first new integration technique is going to result in inverse trig. Okay, so like arcsine, arctan, those are the big two you need to know. The other ones are so similar that you really don't get tested on them. But, so, and then the second one is going to be, we might have to pass off to some long division to break it down before we can integrate it. Both of these have very big triggers. And by trigger, I mean, when you look at it, you're going to see something that's going to make you kind of think, this might go arcsine. I know that's not a word, but you're going to look at it and say, it looks kind of arcsine, and long division has a trigger as well, and I'll tell you what those are. So we're going to start with part A, which is just some integration that results in your inverse trig functions. But before we do that, I want you to kind of remember the derivatives of them, because you'll be practicing those tomorrow on your very first review. There's going to be some derivative taking skills, two of them primarily, the inverse trig, and what other one did I put on tomorrow's? Implicit, because those are kind of two big ones for derivatives. So I want you to remember that when you do the derivative with respect to x of arctan u, it's been months, and it was just a one-day lesson months ago. So it's something that, there's some of that in here. I know you guys probably all remember how to decide if a function's increasing, you take its derivative. Or that acceleration's the derivative of velocity. There's some stuff that I know has not left your memory. That stuff I don't need to review a whole lot. But my guess is most of you forgot how to take this guy's derivative. I kind of referenced it with one of them's nice because it has a tan, it's prettier, and the other one is not so pretty. So do you remember me saying that? Like arctan is the prettier one, and I said for two reasons. So can you kind of remember what those two reasons were? Maybe even just loosely? Yeah, go ahead.
No square root.
Yes. So, yes, arcsine has a square root. So, and then we'll talk about the other ones in just a second. They all have the same thing on the top of the fraction. Okay? This one will have a square root on the bottom. The other one won't. Yep. Steve?
There's a plus.
There's a plus that makes this one nicer. So that's kind of the distinction. Otherwise, they look pretty much identical, correct? Do you remember what's on the top of all of them? U prime. Yeah, and I proved why. I think because I'm videoing this, I don't want it to go. I'm going to next hour, but I don't think I'm going to this hour. But it's U prime over. And then on the bottom, do you remember what was under there? 1.
U squared.
Perfect. And same here, and same here. So that's the derivative. So like if you were taking the derivative of arctan 5x, it'd just be 5 over 1 plus 25x squared. It's a very easy model to use. It just gets forgotten because honestly it needs to be memorized. So there you go. I'm not going to prove that in this hour if you don't mind. If you're interested, it'll be on the board tomorrow because I'm going to have the next hour's going to be at the whiteboard back there. All right. So that was just kind of a remember. Now we're going to talk about integration rules. So when you integrate, and you've got this du over here, okay? And remember, integration is the inverse of derivatives. They work forwards and back. They undo each other, right? So if I were to take my u prime and write it as du, don't write this down right now yet, because I'm going to tweak one thing on here. What would this have to be? Arctan u, correct? Right? If arctan u is 1 over 1 plus u squared du, then if I integrate this, wouldn't I get arctan u? Yes? Right, so that's pretty obvious, but you're going to have ones where there's not always a 1 right here. It's not always going to be 1 squared. It might be some other number squared, so I'm going to put an a squared right there. You might see 1 over 9 plus 25x squared. Or on my example, it looks like I'm going to be doing 2 over 36 plus 25x squared. That'll be our first example. This always passes off to, again, something you need to memorize, because I can't prove it until after the AP exam, because it requires something called integration by trig substitution, and it's not tested on the AP test. You should know how to do it, especially those of you going off to college, so we will do it. But when are we going to do it? after the AP test, because it's a good 2 to 3 day thing and it's not tested. So I don't have the time to do that right now. But we will show after the AP exam that this is always equal to 1 over A arctan U over A. And kind of interesting enough, years ago, I said, you guys, you keep forgetting it. We need a good way to remember this. And then somebody said something and it's made it stick for 5 years since. They had just come from anatomy. Miss Mitzix, and anyone in her anatomy? Oh, they're on a field trip right now. They came from her, they had just done urine analysis before they analyzed their urine. And somebody said, well, let's remember it with urine analysis. I'm like, that'll do it. So this one's 1 over analysis, arctan urine analysis. You'll remember it. It's stupid. But for some reason, like even if I would ask BC today, they go 1 over analysis, arctan, it works. I don't know why. The sine one is really similar. Again, you're going to see a square root, and that's what's going to kind of trigger it. You're going to see stuff squared. I kind of like to call that, it looks Pythagorean-y, like it's got the a squared and b squared sort of in it. This one passes off to almost the same thing, but there's no 1 over a in front of it. All right? So arc sine u over a plus c. That's really it. You just need to use the models. Here's the tricky part, though. What causes some, I want you to circle this and I'll tell you why. This messes some kids up. All right? So I'm going to go do 2 examples of this, and then we're going to talk about our next technique. So my first example, I think I'll go forward a page here. Hopefully I have a blank sheet. I'm trying to turn. It's not letting me grab that. All right, we're going to do the first example right here. Example number 1. All right, it's going to be, I'm going to keep it the same as next hour. So it's going to be a 2 on the top. And on the bottom, 36 plus 25x squared dx. So go ahead and write that down. 36 plus 25x squared dx. Always try U sub first. And let's kind of review that because we're done. We took our last chapter test. You're done with unit tests. For U sub, who do you think of being your U?
36 plus 25.
Yeah, if there's no inside function, we look at the denominator and we hope a multiple of its derivative is in the numerator. But I get a 50x and I can't create an x with a fraction correction. Correct? If it's just a number, and if there was a 2x up here though, that's now, notice just one fine difference, that's now a U sub problem. Does that make, you're nodding at me, right? So you go there first, and most of the time it's a winner. I'm just talking about when it's not. And on here you'd be going like, well, crap, what else am I going to do? This looks very what I would call arctan. What is it about it that makes it to me look like it's very arctan? I know that's not a word. But I have a squared number, I have a plus, it's very squarish down here. It's very pretty, it doesn't have a root, it has a plus. To me, this looks very arctan. Wouldn't you agree? So what you need to do is identify your A, your U, and your DU. So you have to be very careful. First thing I would do, though, is what we always do. I'd get that numerator, that constant, and just get it out of the mix. So I'm going to do a little rewrite, and I'm just going to get that constant out of it. All right? It's out. Now, I'm going to down here, I need to write it as 1 over a squared plus u squared du. Once I can get it written like that, I can pass off to my model. The A is a piece of cake. Who's my A? Done. Okay? I now have 1, I'd like to start rewriting it. I'm going to just show you the model. I've now created 1 over a squared. The plus is already there. The u is easy peasy. Who's my u? 5x, correct? I've now just created that. This is where you have to be careful. Be very careful. Because what is my du? 5 dx. I need to replace that dx. Correct? I don't need to replace 5 dx. I just need the dx. So what am I going to have on this one in addition to the model? 1/5, yeah. Yeah, those of you who are good at U sub, it's got a similar vibe. So my dx is going to be replaced with 1/5 du. And our constants come out front, so watch what I'm just going to do. I'm going to go like that. and then I'm going to go like that. That's what gets missed the most. All right, so that's why I said watch that du, because you might need a fraction correction. Now, if this was just 36 plus x squared, I'm gold. All right, so now I'm going to use my model. The 2/5 is there irregardless of the model. The 2 came out front because it's sitting on the top, and the 5 is on the bottom from a fraction correction. So that has nothing to do with this guy right here. So now I have to use this guy. 1 over analysis. What's my A? 6. Arctan. Urine analysis. 5x over 6. And then what do we always have? Plus Carl. Yep, if I can fit him on. So plus C. So you would say 1/15 arctan 5x 6. What do you think? I told you it wasn't difficult. It just, we didn't do it. All right? And honestly, will you use this a ton on the AP exam? What do you think? It'll probably happen once. It'll probably happen in a multiple choice where you're going, what the heck? I can't integrate this. And maybe you go, oh, looks a little arctan. That, I mean, it happened at most one time, but I would like to at least give you the opportunity to ace it, even though nobody in the world did last year. Sometimes people do, but not very often is there anybody who aces. And if you do, you get me a big deal off. Okay, so next up, my example number 2, because it looks like I'm not being allowed to turn the page, so we're just going to throw it on here. So if you were to, and then we're moving on to technique number 2, square root of 16 minus 9x squared down here, and a dx. All right, I would think of letting u equal 16 minus 9x squared, hoping to pass to u sub, but my du is a negative 18x, and I can't get that x, so u sub's out. And this, I would say, looks very what? Arc-signing. Not a word, but it is now. All right? So I would start this one and say, well, let's get that constant out front. It'll be in my answer, irregardless of when and how I use my model. All right? So arc-sign, again, needs the a, the u, and the dx needs to pass off to du. So my a in this problem is obviously a 4. My u, my thing being squared, is obviously 3x. My du, unfortunately, cannot replace dx. It can only replace 3dx, which unfortunately isn't what I have. Agreed? So we're just going to fix that and replace dx with a third du. Okay? So when I go do my rewrite, here's what I would have. What's going to be in front of mine? 5/3. Exactly. The 5 because it was there. Boom. And then you don't have to write this on your homework or on a test or on the AP test, but I'm just going to show you I just created the perfect model that I can now pass off to, right? And what did I say this one passes off to? 5/3. Is there anything in front of the arc sign? No. It's only for tangent. You just don't know why that is yet. And unfortunately, that's a long thing to tell you. You'll go, oh, that's why, but not until me. All right? So you just have to remember it. 5/3 arc sign, and then what will be my argument for arc sign, or what's in here?
3x over
U over A. What was my A again? 4. And then don't forget Carl, because these are indefinite intervals. That's it. That's my spiel on that new method number 1. Good. You think you can handle it? All right. I didn't assign a ton of them. Let me cancel this. Next up, I wanted to, oh, that's why it's not working. I was wondering why my fingertip wasn't doing anything. It was programmed to be a highlighter. Sorry. So now I should be able to turn the page. Yep. All right. And let's get a new page. All right. So our next one, go ahead and write B. And it's going to say, we're going to be using long division. Yes?
You forget Carl.
I did, because I ran out of room on the edge of the screen. So not mentally, just physically. Thank you, though. All right, so for part B, sometimes what's going to happen is you're going to need to pass off to long division, as you might have thought, why in the world did they ever teach me long division? Like, what's its purpose? Its purpose is actually not much, except for it sometimes helps us integrate. You have to do it sometimes to integrate. That's really the only time you'd ever do polynomial long division that I've ever had in my math career. But when I need it, it's the only thing that works. So I'm going to tell you what the trigger is for it. You use it when, or you try it when, because it doesn't always work. But you try it when the degree of the numerator is greater than or equal to. So it can be tied. Like it can be 4x squared plus 3x plus 1 over 3x squared plus whatever. So when the degree of the numerator is greater than or equal to that of the denominator, I'm going to tell you what it always passes off to as well, because sometimes if it's multiple choice and you know it's a long division problem and there's only one that has something in it, you don't even have to use it. Because it always passes to, what I mean is, once you use it and you use it correctly, when you integrate, it's always going to pass off to some sort of natural log in your answer. You might say, what the heck, how does that happen? I'll show you. All right, so I have two examples of this as well. Number one, I'm going to make a polynomial over a polynomial where the degree is greater, and we're going to do a definite integral this time. So our answer is going to be a number. And on the bottom, I'm going to have a first degree or a linear polynomial, and on the top, I'm going to have a quadratic or a second degree. And I'm looking back there if I'm creeping you out. Stephen, I'm not looking at you. I'm looking at what's behind your head. All right, so there's my problem. All right, so obviously I tried u sub first, and it's a colossal failure. Wouldn't you agree? Like, if it's the denominator, my derivative is 1, there's no way I'm getting an x squared and an 11x and a 7 out of the number 1 with a single numerical correction, correct? That's a huge... Also, if I let it be the numerator, I get 4x minus 11. Like, it's so, u sub is so not helpful. It doesn't look remotely arc-sine or arc-trig-y. It appears that I'm completely stuck. But do you notice how the degree on the numerator is greater than that of the denominator? That's the trigger for, I probably need long division. And so we have to go back to Algebra 2. I don't think they do it in pre-calc, do they? I don't know. I don't teach pre-calc. Did you guys do long division in pre-calc last year? No? Right. I know it's Algebra 2. And actually, exponential algebra, they do as well. So you should have done it twice in your careers. But I need to divide the numerator. I'm just going to rewrite my integrand. I'm going to actually divide it and get something new to put in there, but the new thing I'll be able to integrate. So watch what I do. I don't know how you were taught long division, but I always just say start with the left, stick to the left, divide them, and 2x squared divided by x is 2x. Write it over its like term. Okay, so you know when you reach the end of the bar. Then do you guys remember what to do with your 2x? Because usually kids forget long division, but it's so easy. Multiply it back, right? You multiply it here, and you should always get a match. That's why you divided it. Like you don't, thumbs up, right? And then this would be a minus 10x. Do you remember what you do once you have those two things? You're going to subtract the two levels. So if you'd rather add and change the signs, that's actually safer. So I'm fine with that. And then you write down what you have left. I'd have a negative x plus 7, correct? I'm not done yet because I can still divide. So I always say stick to the left. What's negative x divided by positive x? Minus 1. I'm now at the end of my bar, which means over here is going to be my remainder. I multiply that back in, I get a negative x plus 5. All right? And then I subtract my two levels, or as Clara said, you can instead add the opposite if you fear you're going to have a sign error. What's my final thing that I'm left with? 2. Now, in exponential algebra, here's the difference. The 9th graders learn to write remainder 2. That's not going to be helpful for us. Okay? We're going to do it the way you did in Algebra 2. You write it as 2 what? Over x minus 5. So you write it as plus 2 over x minus 5. This is what you're going to integrate. Do you see how easy that's going to be to integrate now? So we took something we couldn't integrate. We used a little Algebra 2 to break our integrand down into a new integrand. 2x minus 1 plus 2 over x minus 5 is my new one that's equivalent to the old one that had me stuck. And this guy's easy peasy to integrate. Are you ready? What's the antiderivative of 2x? X squared. And of 1? X. And of 2 over x minus 5? 2 natural log what?
Absolute value.
Absolute value x minus 5. Exactly. And beware, because just in case, I'm going to go, don't write, if I write it in green, don't write it down. It's just me not wanting to do a zillion examples. I only want to do 2. But beware if this had been a 3x minus 5. What would that add to this last antiderivative? 2/3. Exactly. All right, done right there. But this was a definite integral going from 3 to 4. So now we're going to review our fundamental theorem of calculus. So lots of review in our new stuff as well. So which number do I put in first? 4. And I go 16 minus 4 plus 2 natural log absolute value. You see why they're important, because I can't do the absolute value at the natural log of -1. That's what I get when I put a 4 in, correct? Are we good with that? What is this? Why? Natural log of 1 is 0. Natural log of e is 1. You need to know those for sure. So this is going to be 0, right? And then what do I do after I put the very first, the top one in? Subtract. And I put a set of parentheses so you don't make sign errors. And then you put the bottom in. 3 squared is 9 minus 3 plus 2 natural log absolute value -2. And I actually took this one out of delta math, so this is kind of what your delta math is going to look like. All right? So then I'm just going to go ahead across and do it. 16 minus 4 is 12, correct? And I need to subtract 6. And then subtract 2 natural log of 2. All right? So what's my final answer? What would you enter if this was delta math? Because I don't know the natural log of 2 and you're not going to round. So you're going to go 14. No, sorry, I lied. 6 minus 2 natural log 2. And you'll be done. All right? So that's example 1. Example number 2 is going to be similar, but I just want to make sure I do both cases. I said you use it when the degree of the numerator is greater than or equal to. So I'm going to do an equal to guy, and I'm going to go change out of my ugly colors. So what one do I have back there? I have 4x plus 22 over x plus 6 dx in a definite integral from -5 to an ugly top one, e cubed minus 6. Interesting. I took these right out of delta math. That's kind of a weird upper bound, but whatever. So if I tried u sub, huge failure. The derivative of the denominator is 1 and stuff. Okay? This should trigger long division as an attempt. So we're going to go do long division. 4x plus 22. If it's multiple choice, by the way, you would cross off any answer that does not have a natural log in it right now. Because this always passes to natural log. Okay? Because that remainder goes over the, do you get why? Right? So we're going to do 4x plus 22 divided by x plus 6. 4x divided by x is 4. It's right at the end of the line. 4x plus 24. I subtract the two levels or add their opposite. This is algebra 2, which is why I'm going so fast. Okay? So I would have 4, and then I'm going to have a minus 2 over x plus 6. That's my new integrand. So back to my old integrand, I'm going to replace you with something much easier to integrate. Like almost in my head. In my head. I don't need to write anything down to integrate it now. So we took something that seemed impossible to integrate. Anyone who doesn't watch the notes, who's gone, they're going to have no clue how to do it. Right? But it's easy. So right here, the antiderivative is 4x. What's this guy's antiderivative? 2 natural log absolute value x plus 6. And then plus c if I didn't have limits, but I do. I'm going from -5. Oh, I see why the -5 was chosen. So natural log of 1 will go to 0. That'll be kind of nice. And then I have an e cubed minus 6, and now I get that choice as well. All right, so let's go plug in the e cubed minus 6. 4 times e cubed minus 6, kind of ugly, minus 2, natural log of what? What's it going to be? Natural log of? What did I tell you? E cubed. Yeah, absolute value of e cubed, but e is positive, so I can dump those, right? What is the natural log of e cubed? 3. That's why I was like, remember me saying that's a weird upper bound? That's why it's weird, so that things work out nice. So this is going to be passing off to a 3, just the number 3. Then I've got a really long bar here. I'm going to shorten it up so I can fit the rest of my problem in without going to a new page. Then I'm going to subtract off brackets. 4 times, I'm trying not to make it, this is where I choke, like I'm not good with arithmetic. I'm sloppy. I would say, yeah, you would. Super sloppy with it. All right, so I'd have a negative 20 minus a 2 times the natural log of what? 1, which is 0. So it looks like all I need to do is add 20 to this. So what is this? This is 4e cubed minus 24 minus 2 times 3 plus 20. All right, I didn't make any mistakes, did I? All right, what am I at? 4e cubed minus 10. Yep. Did I make a mistake?
I think you got the negative 6, the minus 6 of the natural log. The first part.
No.
Minus 6.
It's
No, because I did e
never mind,
cubed
never mind.
minus
Oh,
6
never
plus
mind.
6.
Never mind.
Cancel. I was like, oh no, I'm all the way at the end. All right, no, I'm good. So it looks like it's 4e cubed minus 10, right? So that's it. Our 2 new integration techniques. They have triggers, like you'll spot them. You're going to go to Delta Math. I will collect your work for Delta Math. Now, here's one thing before I hit pause. Delta, I'm talking loud because I don't have my headset on. Why is you talking so loud? It doesn't pick up my voice if I don't talk loud. In Delta Math, they use synthetic division. Don't. Because the specs for AP says you have to know how to do it by long division. It says nothing about synthetic. So synthetic will give you the same result, but you're supposed to use long division, which is actually far more powerful than synthetic, to be honest, because synthetic requires you to divide by even your term, which isn't always the case. Anywho, go ahead and start in Delta. I can't remember how many I have in there, but they're specifically chosen so you all do have the same problems if you want to work with someone. Alright, so if there's anyone, I did that in case you wanted to clear up for 10 minutes or whatever. I'm going to pause.